Welcome to everybody. Yesterday, we have to study. So, what is the definition of limit and what is the definition of continuity? So, what are the properties of continuous function? So, let us see here. Properties of continuous function. What are the properties of continuous function? Okay. So, what is the theorem here? So, very simple property. Theorem. If fx and gx are, if fx and gx are two continuous functions at two continuous functions at x is equal to a. So both are continuous functions fx and gx at x is equal to a. Then one f plus g, second f minus g, third f into g, fourth f divided by g are also continuous at x is equal to a. Very simple theorem here. If fx and gx are continuous function at x is equal to a, then prove that f plus g, f minus g, f into g and f divided by g are continuous function at x is equal to a. We prove that theorem here. So that is the first. F plus g is continuous at x is equal to a. So what are the given here? So fx and gx are continuous function that is given, but we have to prove that f plus g is continuous at x is equal to a. So given that fx is continuous, means fx is continuous at x is equal to a. So that is the limit of fx at x is equal to x tends to a is equal to f of a. Since f is a continuous function, then definition is what here? Limit of fx as x tends to a is equal to f of a. So this is a simply definition, notation here, notation of continuous function. Similarly, gx is continuous at x is equal to a, then we can write here limit of gx at x tends to a is equal to g of a. Okay, so that is given here. Fx is continuous having limit f of a, gx is continuous having limit g of a. So now we prove that. So this f plus g is continuous at x is equal to a. So therefore limit of f plus g of x as x tends to a is equal to this can be written as limit as x tends to a f of x plus g of x. So that is f of x plus g of x. So we shall write this. So limit as x tends to a of fx plus we separate this limit here. So limit as x tends to a of gx. So this is equal to. So by definition of limit of a function fx as x tends to a is f of a. So this is f of a What is this? This is g of a. So we can write this in the form, so f plus g of a means here limit of f plus g of x as x tends to a is equal to f plus g of a. Therefore f plus g, by using this definition, f plus g is continuous at x is equal to a. So this is a very simple proof here. So now we prove the second f minus g. So how can we prove this f minus g? So we write here. So second is what here? Second f minus g. So simply write here minus instead of plus. So this is a minus f minus g. So limit of f minus g of x as x tends to a is equal to fx minus gx. Fx minus gx. So similarly we can write this is minus. So this is also minus. Okay. Then this can be written as f minus g. So this is f minus g. So similarly, second result is what here? So that is f minus g is continuous at x is equal to a. Okay. So this is a very simple proof. So we prove this third property here. So f dot g is also continuous at x is equal to a. So we write the operation multiplication instead of minus, and we can easily prove that for f dot g is also continuous at x is equal to a. Also we can prove this property f divided by g is also continuous at x is equal to a by replacing the operation minus instead of minus. So division, we take here division operation instead of minus operation. So and we can easily prove that these properties of a continuous function here. Okay. So now we take example. We take example on continuity. So there are very simple examples. So how to find the limit of the function here, and if the limit is exists, then the function is continuous. So we also, in the last lecture, we studied what is the left hand limit, what is the right hand limit, what is the limit. Then if left hand limit and is equal to right hand limit, then the limit is exists there. Also we studied the definition of continuity, discontinuity, removable discontinuity, irremovable discontinuity. So that is very simple concept here. Okay. So take an example. Examine the continuity of fx if fx is equal to, so function is given here 9x divided by x plus 2 if x is less than equal to 1 is equal to x plus 2 when where 1 is less than equal to x less than equal to 2 is equal to x plus 3 divided by x if x is greater than equal to 2. So that's the continuity of the function here. So what is the solution? So what is the function given here? Fx is equal to 9x divided by x plus 2. If x is less than equal to 1, is equal fx is equal to x plus 2. If x is 1 less than equal to x less than equal to 2, and fx is equal to x plus 3 divided by x if x greater than equal to 2. to test the continuity of this, examine the continuity of this function. Okay, so we need to consider, or we check the continuity at the point x is equal to 1 and x is equal to 2. To consider the continuity at x is equal to 1 and x is equal to 2. X is equal to 1 and x is equal to 2. So why your test here the continuity of the given function at x is equal to 1 and x is equal to 2? So that is a very simple one. So we draw simply graph roughly here. So this is not possible to draw the graph of this function correctly. So this is the x-axis. So this is the y-axis. This is the origin here. So what is the function? If fx is equal to 9x, so this is the here 1 is here, then 2 is here. Okay, 1, 2. These are the scales here. 1, 2. You just consider the graph here roughly. So what is this function? Fx is equal to 9x upon x plus 2. So that is what happened here. So something, this is a function here up to this. So this is the 9x divided by 2. This is the function here. Then x plus 2 is something straight line here or something. This is not exactly x plus 2. So this is the function fx is equal to x plus 2 in the interval 1 to 2. Okay, 1 to 2. And then this is the function fx is equal to x plus 3 divided by x is the curve when x is greater than equal to 2, something x is equal to greater than equal to 2. So this is x plus 3 function, x plus 3 divided. You just imagine that this is not exact diagram here. So this is x plus 2, and this is what happened here. So 9x divided by x plus 2. Okay, 9x divided by x plus 2. So it is necessary to check the continuity at this point here. We don't know the function is continuous at x is equal to 1 and x is equal to 2. So it is necessary to check the continuity of the given function at x is equal to 1 and also x is equal to 2. So what is the continuity? So we find the limit of the function at this point. If the limit exists, then point exists. If limit exists some finite, then the point exists there. So we check the continuity at x is equal to 1 and x is equal to 2. Okay, so you understand. So why you have to check the continuity of the given function at x is equal to 1 and x is equal to 2. So okay. So what happened here? So just so what is the limit, left hand limit of fx? So we check first the limit of the given function at x is equal to 1. So that is x tends to 1 minus. So this is the left hand limit. Means x approaches to 1 from the left side. So this is x less than 1 means on the real line. Just we see the graph of the function. When therefore this is equal to limit of fx is what here? Left hand limit. So this is 9x divided by x plus 2. X plus 2 as x tends to 1 minus. So this is a left hand limit. So x tends to 1 from the left side. So that is okay. So this is what happened here. So put x is equal to 1. So this is 9 divided by 1 plus 2. So that is 3. 9 divided by 3 is 3. So now we find the right hand limit. Limit as x tends to 1 plus fx is equal to limit as x tends to 1. So this is a right hand limit, 1 plus. So what is fx? Fx is, so we come, so x approaches to 1. So remember the diagram here, so the graph here. X approaches to 1 from the right hand side. And in between 1 and 2, in between 1 and 2, the function is x plus 2. X plus 2. Function is x plus 2. Since here just remember the this is 1, so this is a 2, so this is x-axis, y-axis. So okay, so this is something, so this is something, so this is the curve of this function, this is the curve of this function, and this is the curve of these functions. So x approaches to 1 means x less than equal to 1. So we take example, we take this function 9x upon x plus 2 and find the limit. So this is x approaches to 1 from the left. So this is the left hand limit. So x approaches to 1 from right hand limit. So in between 1 and 2, the function is x plus 2. So that is x plus 2. So put x is equal to 1. 1 plus 2 is equal to 3. Yeah. 1 plus 2 is 3. So what is this? So left hand limit is equal to right hand limit. So limit exists there. So limit of fx as x tends to 1 minus is equal to limit of fx as x tends to 1 plus. Therefore is equal to 3. Therefore fx is continuous at x is equal to 1. So at point 1, so fx is continuous function. So there is a point, so this is the continuous function at x is equal to 1. So now we check the continuity at x is equal to, so second, continuity at x is equal to 2 here. So now we check the continuity at x is equal to 2. So what is the limit of fx? So we take here first left hand limit. So x tends to 2. X tends to 2 minus means left hand limit. So then function will be here. Function will be here what? So x tends to 2. So x tends to 2 here. X tends to 2. X tends to 2. The function will be what here? In between 1 and 2. So that is x plus 2. So this is x plus 2. So this is what happened here? X plus 2. So this is 2. 2. So this is what? Put x is equal to 2. So that is 2 plus 2 is equal to 4 here. 2 plus 2 is 4. Okay? So the left hand limit of the function at x is equal to 2, x is equal to 2 is 4. So now we obtain the right hand limit, x tends to 2. 2. So this is the right hand limit. Right hand, x tends to 2, x tends to 2. So x approaches to 2 from the right hand side. So that is x tends to 2 plus. So this is right hand limit. The function will be this, because x greater than equal to 2, x greater than equal to 2, the function is this, so that is x plus 3 divided by x. So this is what happened here, x plus 3 divided by x, so that is 2 plus 3 divided by 2, so this is 5 by 2 here. So at x is equal to 2, left hand limit is 4, and at x tends to 2, the limit, right hand limit is 5 by 2. So here left hand limit is not equal to right hand limit. Okay, so left hand limit is 4, right hand limit is 5 by 2. So left hand limit not equal to right hand limit. So therefore fx is not continuous or discontinuous. So fx is discontinuous at x is equal to 2. So this is a very simple example. So how to check the continuity of the function? So we need to check the continuity at x is equal to 1 and x is equal to, so at x is equal to 1 the function is continuous, and at x is equal to 2 the function is discontinuous. Okay, so we take another example, very simple example taking here. So examine the continuity of fx. So take another example. So examples are very simple here. Okay. Examine the continuity of fx at x is equal to 0. If. So what is fx? Fx is mod x upon x. Mod x upon x, where x not equal to 0. Otherwise, so f of 0 is equal to 0. When it is, so when x is equal to 0. If x not equal to 0, fx is mod x upon x, otherwise 0 here. So test the continuity of the given function at x is equal to 0. Is it continuous function? This is the, so we check here, this function is continuous at x is equal to 0. Okay, so then what is the solution here? So what is the definition of mod x? We know that. We know that. We know that. So what is the definition of fx is equal to mod x? So what is the definition of mod x? So what is mod x upon x? Fx, just mod x is what here? Definition of mod x is x when x is positive. When x is a positive. Mod x is x when x is positive, and mod x is minus x if x is a negative. Means both are the positive values here. Since x is negative, this is a negative and negative, this is also positive. So mod x is always positive. So mod x is equal to x if x is greater than 0, and is equal to minus x if x is less than 0. So now we obtain here the left hand limit. So that is the limit of fx. We check the continuity of the given function at x is equal to 0. So that is x tends to 0 minus. So this is what happen here. Minus means left hand limit. So that is limit as x tends to 0 minus. Fx is what here? Fx is, so this mod x upon x. So as x tends to 0. So just what is the graph of the mod x function? So this is the mod x function. So this is fx is equal to mod x. So we draw the graph of this function here like that. So this is the mod x function. Okay. So we check the continuity at the point 0 here. So x approaches to 0 from the left hand side. So we take here the left hand limit as x tends to 0. So we take when x is less than 0. X is less than 0. So we take minus x. Mod x is minus x. X less than 0. So all these values here from 0 to minus infinity are negative values. So these are the negative values. So we take minus x. So divide by x. So minus x divided by x is minus 1. So this is the left hand limit of this function here. Okay. So we now find the right hand limit. So limit of fx as x tends to 0 plus. So this is the right hand limit. So is equal to limit as x tends to 0 plus. So this is the right hand limit. So what is the function here? Function is fx is equal to mod x upon x. Mod x upon x. So we take here. So what is the right hand limit? So x approaches to 0 from right. So all those values from 0 to plus infinity, these values are positive. So these values x greater than 0 means all values are positive. So we take mod x is equal to x, simply x, positive. X is positive here. Divided by this x. Mod x is equal to x divided by x. So x upon x is 1 here. So what happened here? So we get here left hand limit is -1 and right hand limit is +1, means the left hand limit not equal to right hand limit. So limit of fx as x tends to 0 minus not equal to, both limits are not equal, so that is limit of fx as x tends to 0 plus right hand limit, both limits, the left hand limits and right hand limits are not equal, therefore the given function fx is equal to mod x is not continuous. Is not continuous means is discontinuous. Discontinuous at x is equal to 0. So these are the very simple examples. So how to obtain the continuity of the given function. We check here, examine the continuity of the given function at the given point here. So these are the very simple example. We stop here. Thank you.